One of the first things that C++ programmers need to learn how to do is control input and output. And generally, we start by learning how to control text-based input and output, or how to generate text-based input and output. And the way that that is typically done in C++ is by way of the cout object. Now, at this point, there's a good chance that you haven't yet learned about objects and classes, and so I'll describe cout in this way. Built into C++, we have several data types, such as int and float and double and so forth, and we can create variables of those types. So cout is an object of the type iStream. So iStream is kind of like int and double and so forth, but instead of being built into the C++ language, someone built it out of the C++ language. So they wrote a bunch of code that describes the kind of object that cout is. And that description is called a class. And so the class acts kind of like the type, and cout then is an object or an instance of that class. So where we might have a variable of type int, we have an object of the class iStream. Okay, so I hope that helps a little bit. You don't need to fully understand, but those are the basics behind the relationships there. Now, for the purposes of this presentation, it's okay to think of the cout object as a machine. It's a machine built out of software, but it's a machine. And we're going to interact with that machine in order to generate text-based output on the screen. Okay? So here I've created just a simple diagram to try to convey some of the basic ideas upon which cout is built. So this box here is the machine, and you'll notice that it has a button on the top and a tray sitting off to the side. And we'll talk about those in a moment. Now, you'll also notice that cout is connected to the display, but not directly. There's this thing in between cout and the computer's display that we refer to as a buffer. Okay? And what this buffer is basically just a temporary storage area. So when we want to put something on the screen, instead of going straight there, it will first go to this buffer. And then the buffer flushes itself to the screen, or puts its contents onto the display periodically. And generally we won't be in direct control of that, but we usually don't care because it puts things to the screen pretty quickly and pretty frequently. To us, it generally looks like it's instantaneous. There are ways that we can force the things that we send to cout to pop up onto the screen immediately, or in other words, to force the buffer to be flushed immediately. And I'll talk about one of those ways a little bit later in the video. Okay, so let's take a look at some of the pieces then of cout. Again, I mentioned this button, and you'll notice these left-facing chevrons on the button. This is the button we will use to tell cout that we'd like to take something from the tray and put it into the buffer where it can eventually end up on the display. Now, when we learn more about cout, or when you learn more about cout, you'll learn that there are other things we can put on the tray aside from simply things we want to put on the screen. There are things we can put into the tray and hit the button that will cause cout to change the way that it behaves. That's beyond the scope of this discussion. I did want to just mention that that's a thing, but we're just going to focus on how do we use this to print things onto the screen, to get messages onto the screen, and so forth for now. Okay, so this is kind of the conceptual model that I'd like you to have in your head. Now let's look at some code that actually utilizes this cout object, this kind of machine that we're thinking about. So I've built just a very simple sample program here that I've called simpleoutput.cpp. And just a couple things to point out. You'll notice that I'm including something called IOStream. So as I mentioned, cout is not actually part of the C++ language. And so in order to use it, I need to include code that talks about it, that describes it. And we do that by including IOStream. So the compiler will pull in the contents of IOStream and learn about cout so that we can use it properly in our program. I'm also including string. String also is not built into the C++ language. It's another class that we use. And we see here that I'm creating a string called aString, and it behaves much like our other data types in that we can assign values to it and so forth. And we'll see that we can use it with cout to put things on the screen. But again, I just wanted to emphasize the fact that that our strings are also actually data types that somebody built for us, and we get to leverage their code. So that's pretty cool. Okay, I've got some variables being declared, but for now I'd like to jump down to the cout statement, where you see that I'm invoking the cout object, so I'm referring to it, and then I'm using the insertion operator followed by a string literal. And a string literal is just characters inside of double quotes that's built right into our code. So this string is literally embedded in the code that will become the program that we're going to compile in just a moment here. So this is a little bit different than, say, a string or words that the user might provide for us. This is a string or words that we have literally indicated in the code. So again, it's called a string literal. So this will simply say hello and then print a new line character. So this /n simply indicates that we'd like a new line character to be inserted. And by that we mean the effect of hitting the enter key, causing us to go down to the next line. Okay, so let's go ahead and build this and see that it works. We expect that here where we're kind of smashing that button, that the next thing is the thing that's sitting on the tray. And what we're doing then is we're telling the machine, hey, go ahead and take that and put it out in the buffer to be printed to the screen. So let's try that. Okay, so I'm just using the G++ compiler. And again, this was called simple output.cpp. So I'm compiling that. I didn't provide an alternate name, so the compiler is using the default name of a.out. And I run it, and there we go. We see the word hello printed to the screen. Now, because we placed the new line character, it printed the word hello and then jumped down to the next line, which is what we wanted. If we hadn't done that, then the word hello would be appearing right here in front of this string talking about where I'm actually at in my file system and so forth. And so it would be less neat to look at. Okay, so that's the basic pattern we'll use when we're using cout. Now I'd like to show you just a couple more options we have available to us. So switch back over here to our code. All right, so again, I'll draw your attention to these variables that I've created, and I've just placed some values inside of them. So in addition to printing string literals, we can also use the cout object to print variables. And works the same way. Effectively, we put them on the tray and we smash the button. Okay. Now I should mention, if I didn't already, these two characters here that I'm representing on this button, together they're known as the insertion operator when we're using them with an object like cout. Okay, so I'm going to modify this line of code, and instead of printing simply hello, I'm also going to instruct cout that I would like to print out, in this case we'll print out the string a string. So I can just place the insertion operator again. We can use the object more than one time on a single line or in a single statement. And so here I'll just use it again, and I will print a string. Okay, now we'll go ahead and run it this way, and we're going to see the effect of not printing a new line last and how that causes things to come out. So let's go ahead and look over here. And we'll compile it again, get the changes to our code, and then run it again. Okay, so here you see hello as before, and then we went to the next line. But now you'll notice the word uninitialized that showed up on the same line as my command line prompt. And so that's kind of what I was talking about in terms of it doesn't look real nice. So we got the idea that we can print two things, but we want to have a new line after this string called a string. Now, one way we might deal with that is we could start a new string and put a new line character, a new string literal, and put a new line character like this in it. That's one thing we could do. Another thing, however, is that we can use what's known as the endl object. Okay, now endl is also declared up here inside of IOStream, and so I can use it to print a new line or an end line. Now, a quick note to make. Endl isn't actually just called endl, nor is cout just called cout. They actually belong to what's known as a namespace called standard. And so one way to use them, once I've included IOStream, would be to type std::endl and std::cout. But that's a lot of extra typing, and so kind of a shortcut is we can use this using statement where I say using std::endl. And what that does is it tells the compiler, hey, when you see endl, I actually want you to try to go ahead and use this particular endl, the one that's std::endl, and similarly with cout and so forth. Okay, so that's what's going on there. It's just to save me some typing down here. So now let's try this with the endl that's being fed. So quick recap, we put the string hello on, here we go. We put the string hello on the tray, we hit the insertion operator, and off it goes. A string is kind of being placed on the tray as well. We hit the insertion operator and off it goes, and then we did the same thing with endl. And so that's the order things will go in here, is from left to right in terms of how we're going to interact with the object. So let's make sure that works. Looks like I've got some weird things going on there. There we go. Okay. Whoops. Doesn't do me any good to recompile if I didn't save my file. So I didn't save those changes. So we'll do that real quick. Okay. And try it again. And it looks like I've got some weird artifacts going on with my output here. I think that's probably happening because I've got my screen narrowed up so much there, the window. So I'll change that in a minute and see if that helps with that. But here we can see that now it's printing hello and then uninitialized the way we wanted. So in terms of general behavior, for most of the things we care about, this endl acts just the same way as it would have acted if I'd put double quotes, created a new string here, and put the new line character inside of it. There is one difference, however, that I do want to point out, and that has to do with this buffer. So it turns out that when we use that endl object and we send it to cout, it causes cout to force the buffer. Well, and I must say I don't know the exact relationship there, whether the buffer responds to the endl object or cout does something special. I'm actually not sure. But the effect is that when we send an endl object into the cout object, it will force the buffer to be flushed immediately. So that can give us some control over that situation if we want it. Again, we almost never care. But if you do, that is one way that you can cause it to happen immediately. Okay, so let's see where that puts us. All right. So we've printed the word hello and then this string that I actually put the word uninitialized inside of, and that's just to indicate to me that I haven't myself placed any data in it since I created it. And what I want to do now is show you what happens if I just put a string followed immediately by, there's my cursor, followed immediately by HR, and that's probably where I'll leave this. So I'm going to put another insertion operator and then HR, and let's save that. There we go. And give that a run and see what we get. I did say I was going to stretch this out a little bit, so I'm going to go ahead and do that. Yeah, I think that'll work a little better. So I've recompiled. We'll run it. Okay, so now you see again the word hello, but now uninitialized is followed immediately by this character, HR, that contains an exclamation mark. And so what I wanted to demonstrate there is that sometimes we do want things to appear immediately right next to each other when we're outputting them to the screen. And so that's just an example of a situation where we might do that. Okay, I think that's where I'll leave that. Again, this has just been a basic introduction to the cout object and how we can use it to generate text output to the screen. There's obviously a lot more to learn about the cout object, but this should get you started and on a path to doing just that, learning more about it. Thanks.